Okay, so I think we can go ahead and get started. So hello everybody. Again, thank you for coming today, especially on short notice with today's orientation. I am Hayden Fennell, the coordinator for this year's CompuCell3D summer training workshop. You've all already heard a lot from me over the last few weeks via email, so it's good to finally see some people virtually in person. Just a couple of quick notes before we get started here. Just want to let people know that this session, as well as all future workshop sessions, will be recorded and live streamed on YouTube. So just something to be aware of moving forward, that these sessions are recorded and live streamed for future viewing on YouTube. This slide deck is available at the following link. Let me actually go grab that for everybody. And here in the chat is a link to the student materials folder. So you can go find the slides from today in this folder in the subdirectory just called orientation. There is an activity at the end of the orientation just for setting up a very simple simulation. If you'd like to try to get the CompuCell install started now, you can go ahead through the link here with the source bin. Otherwise, there will be a little bit of time in between basic orientation and the activity to get CompuCell installed. It's okay if you don't have it installed yet today, or if you don't want to install it today, you can just follow along and then review the video or the slides later for the instructions. Yeah, so please submit any questions, concerns, suggestions via Zoom chat. I will pause intermittently to try to take a look at those, see if there's any questions or concerns. We do have a Slack channel set up for this year's workshop. So if you use Slack, I will put the link here in the chat. That is a good place to connect with other workshop attendees outside of official workshop hours. And it's also usually pretty crucial in setting up hackathon groups if you're planning on attending the hackathon. So feel free to take a minute and join the Slack when you have a chance. Before we get started, I do want to thank our ongoing funding sources through the NIH and the NSF. They are the groups that allow us to put on this workshop every year. So again, welcome. Thank you everybody for your interest in this year's workshop. We have a pretty good content lineup this year, I think, and we are excited to work with everybody this summer. And looking forward to especially hackathon projects this year as well. So just a couple notes before we launch into the orientation. What are today's learning goals? So first, we're going to go over what exactly is multicellular modeling and why do we need it. We're going to talk a little bit about what CompuCell is, what it's capable of. We'll look at some example simulations of different things that have been done over the years with CompuCell. We'll talk a little bit about what you might need to know to work with CompuCell. We'll identify a couple areas that you may want to read up on a little bit before the course starts, if you want to or need to. We will provide some suggested resources for all of that. So there's not much background that you'll need coming in, but we do have some suggested areas that we think are useful to at least have looked at briefly before the course starts. We'll talk about how to install CompuCell and how to get a basic simulation running, and then we'll talk about where to go for help before and during the workshop. Just a quick re-overview of the actual orientation outline. We'll talk about course logistics, again, basic background knowledge, how to prepare for the course. We'll talk about hackathon logistics as well today, where to find resources, and then we'll go over our CompuCell example. We do have more than 80 people registered this year, so we will do our best to support each of you, but please do be patient. My email inbox in particular tends to get pretty full in July before the workshop. So if you do have a burning question and you email me about it and you haven't heard back within 48 hours, please feel free to ping me again. Don't worry about bugging me. Sometimes emails just get buried, or worst of all, sometimes Outlook groups them in with other emails that I don't want them grouped with, and I don't see them immediately. So if you have something urgent, or if you haven't heard back from me within 48 hours, please don't hesitate to send multiple emails. and I will get back to you as soon as possible. If you are re-attending the workshop this year, or if you have had some experience with CompuCell in the past, we'd love to hear from you as a potential mentor for hackathon groups or as potentially a TA for some of the sessions to help answer questions in the chat. So if you're interested in helping with that, please contact me at hfennell@iu.edu. So what we will be learning to model in this year's workshop, we'll be using CompuCell3D to do virtual tissue modeling, as I'm sure you've already seen through the advertising and all the emails. CompuCell can be used to model a number of different areas of computational biology. It's used a lot for development, so answering questions about how things grow into adult organisms. It's also been used a lot to look at developmental diseases, how diseases progress, and how you go from sort of early set of symptoms to potentially some more serious symptoms down the road, and how that's represented at the cellular level. It's been used to look at infectious diseases, how do pathogens and hosts interact, as well as how do diseases spread throughout a tissue. And it's also been used a lot in toxicological settings. So how does certain chemical concentrations over the course of development or over the course of disease propagation cause certain behaviors in the tissue, and what determines susceptibility to these certain chemical concentrations. And the ultimate goal here is to kind of target all this towards medicine and bioengineering. So how can we use computational modeling to help predict the mechanisms behind some of these issues so that we can repair tissue or create new forms of medication and treatments by using computational simulations that kind of allow us to explore things in ways that are oftentimes difficult or sometimes impossible in experimental settings. So a little bit more about virtual tissues. These are mechanistic computer simulations of cell and tissue organization. And we can use software like CompuCell3D to explore some of the more stochastic and emergent properties that we see during tissue organization. For our scale, CompuCell scale, this kind of dotted box here is what we tend to look at with CompuCell. We're more at the organ, tissue, and multicellular level. We do some intercellular work with network modeling. You can set up network models to do cell signaling between cells. But for the most part, CompuCell kind of sits at this tissue and multicellular level. Some sample simulations over the years that CompuCell has been used for. A lot of CompuCell simulations involve cancer growth. So here in the upper right, we have tumor interaction with blood vessels. This is a vascularized tumor. You can see it kind of, the red lines represent blood vessel network, and the tumor is growing within the blood vessel network. And the purple lines here show that it's kind of how it's sapping the resources out of the vasculature. It's also been used to model polycystic kidney disease here in the upper left, how cysts form on the, sorry, I'm forgetting the word, kidney, renal tubules, that's what I'm looking for. And I believe that this is in conjunction with basically a acetaminophen toxicity in the kidneys. It's also been used for a couple of retinal studies, diabetic retinopathy therapy optimization, so where to target these laser treatments and how certain patterns of laser ablation cause different levels of repair in the retinal tissue. Bottom right here, we have a study on retinal neovascularization. So this is a study of the eye where the vasculature actually grows into the retina and causes detachment. You just saw that in the animation. Saw the 3D on the right here, and then the 2D representation on the left. Actually back that up a little bit. The white dot, I know this is a little bit small, but the white dotted line at the bottom is the substrate essentially. And then you can see as the vasculature grows, which is represented by the red growing into the green retina tissue here, that eventually it will cause retinal detachment, which you can see in the 2D simulation or 2D view on the left. And there it goes. So again, the purpose behind a lot of this is just sort of trying to understand the mechanisms at the cellular level of what's causing these different phenomenons, which we can use to then target treatment and medication towards preventing these outcomes. CompuCell has also been used in a number of toxicology studies in conjunction with the EPA. For example, computational model predicting disruption of blood vessel development at different chemical concentrations. So the blood vessels actually sort of break up, fall apart, depending on the chemical concentration at certain stages. It's also been used to study computational modeling and simulation of genital tubercle development and how that's disrupted by chemical imbalance, as well as a computational model of secondary palate fusion and disruption. This is chemical disruptions during development that cause the disorder known as cleft palate, and how the interruption of that palate fusion results in that prognosis. Again, with the intention of understanding how exactly the chemical imbalance causes that problem and how we can sort of readjust it with medication if it's caught early enough. It's also been used to study some viral infection modeling, some immune response in epithelial tissue. I think this might have been COVID study. I won't get too much into the details of this one today, so we can move on to our next topic. But point being, CompuCell3D has been used over the years to study a lot of different types of virtual tissue systems. So there's a lot of different things that we can do with CompuCell. And if you have any particular models in mind that you'd like to work on, either as a hackathon project or just moving forward after the workshop, we're happy to confer with you to figure out how to best set it up to get the outcomes that you are hoping to study. So by the end of this course, you'll be able to look at a biological problem and ask quantitative questions that can be answered with simulations. So this is one of our big talking points during this workshop, is how to actually take a conceptual biological system, something that you're interested in modeling, and how to scope that down into something that can be modeled computationally. You'll also be able to analyze the components of a multicellular system as well as their interactions, and then translate them into executable CompuCell code. So it's sort of the implementation phase. Once you have your idea scoped out into something that can be modeled, how do we actually set it up computationally? And you'll also be able to build and modify CompuCell simulations using CC3D ML, which is the XML basis of CompuCell, and Python, as well as CompuCell's built-in tools, so that you can learn how to display and analyze simulation data to derive biologically meaningful results. So once we have the simulation set up and running and producing output, how do we make meaning of what we're looking at?
Hi, Hayden. I have a
Yes.
question.
Mhm.
I have a question. Actually, how accurately does CompuCell 3D able to simulate a real system, like a real biological system? What's the level of accuracy of the simulations?
So that is a little bit of a difficult question, because a lot of that depends on how you want to set your simulation up. If you're looking at something, so I think CompuCell is useful up to about 10,000 cells. So if you're looking to model a system that's 10,000 cells or below, it will be decent. It might run a little bit slow at that scale, but it will still run. So what we're really looking at here is sort of subsets of a larger tissue. I'm looking more at kind of local behavior within a tissue. But yeah, it depends on what exactly you're trying to model. CompuCell is particularly useful when you're interested in tracking spatial behavior of your system. So actually cell shape and how the cells kind of interact at their edges. So we can definitely talk more about that if you have a specific model in mind. You can shoot me an email.
Yeah, sure. Also, like, is it difficult to model a real system? Maybe because when we try to broadly model a system, the more broadly we model, the higher the parameters we have to consider. So if you do that, then it's hard to model those, consider all the parameters which are involved. So is it like that?
Yeah, so I mean, this is one of the big questions in modeling, right? Is how do you abstract a very complicated real world system into something that can be realistically modeled, um, on your computer at home? And oftentimes what we'll need to do is break if your system is large and very complicated, we might need to break it down into kind of multiple pieces. And we can maybe talk about that during the workshop about how to take data from one simulation and maybe feed it into another. So there's ways to work with it that allow you to model very complicated things. And we will teach you some of that during the workshop. We also are working on putting together a course at the end of the advanced content week on how to run CompuCell3D on supercomputing clusters. So if you have access to any of those through your institution, we'll talk a little bit about how to set up some of that. So if you do have something very large that maybe runs very, very slowly on your local machine, you could potentially outsource that to some supercomputer time to speed that up. So we'll talk about a couple of different ways of kind of tackling this issue of modeling complicated real world systems with simplified computational models.
Yeah, sure. Thank you so much. Yeah.
Great. Okay, so in the interest of time, I'll go ahead and move on here. But if you do have questions, feel free to drop them in the chat at any point, and I'll stop and take a minute to answer those when we have a chance, because I do want to make sure that we have some time at the end of the session to look at this example. So just a little bit about course logistics, how the course is actually going to work. We will have links for the Python bootcamp, the workshop, and the hackathon sent out at least 1 week before each of those events. We don't have those links set yet. We're not sure if we're going to use the link from today for the workshop or not. I know there were a couple of issues with the time not showing up correctly and it looking like it was going to be daily. So we may take a look at that and generate a new link, but we'll make sure that everybody's notified of that in future emails. So just keep an eye on your email, and we will be sending out payment forms by the end of this week. We finally got our bug figured out, and we'll include all of this information in your intro package. We do have links to our hackathon teaming document up and our Slack channel, though. So if you would like to take a look at those two things and maybe get started on trying to find hackathon groups, if you're interested in participating in that, it's never too early to start forming groups. So we'll have more information about exactly how to use that document and a schedule of pre-workshop hackathon teaming meetings sent out by the end of this week. I think at this point, this is an old slide from the early COVID era. I think at this point, everybody's pretty familiar with using Zoom. We'll go over this during the actual workshop, but the core thrust is if you're having any technical problems, please let us know right away. Before and during the workshop, it's also good to check for Zoom updates on a daily basis. So each morning before you log in, just check for updates and make sure that everything's all updated. When Zoom clients are out of date between the host and the attendees, it will often disable features on the attendee side. So things like polls, certain types of screen sharing, annotations, things like that can sometimes be disabled if your Zoom client is out of date. And we do use polls a lot in the workshop. So it's important to make sure that your Zoom client is updated. Other than that, we will have TAs in the rooms answering questions in the chat and posing particularly relevant questions to the instructor. But we will go over all of that kind of at the beginning of the workshop. Quick list of people. So the workshop is hosted officially by Professor James Glazier at Indiana University Bloomington and myself. Also at IUB, we have our list of teachers here this year. So Gilberto Thomas, Pedro Castel, Julio Belmonte, Jim Sluca, Lorenzo Vescini, Priya Madhyapuk, and TJ Sego are all teaching for us this year, in addition to myself and James Glazier. If you have any questions about the workshop right now, direct them all to me. If I can't answer your question in full, I will forward it to someone who can. So again, please don't hesitate to send me any questions, comments, or concerns you have before or during the workshop, or after for that matter. Daily schedule this year. If you are familiar with the workshop from previous years, we've adjusted the schedule a little bit this year. We're doing 3 modules per day, where we used to do 4. We will get started at 10 a.m. Eastern Daylight Time each day. We open the room at about 9:30. So if people want to join to ask maybe some questions or get help with troubleshooting issues with CompuCell that you're having throughout the course of the workshop, we have about 30 minutes in advance of the workshop each day where you can pop in to ask quick questions. Our first module will go from 10 a.m. to 11:30 a.m. Again, all these times are in Eastern Daylight Time. Each module will be roughly 30 to 45 minutes of lecture on new content and 45 to 60 minutes of hands-on exercises, depending how long each session is. From 11:30 to 12, we'll have what we call our extra sessions. So these are usually just short sessions, typically having to do with hackathon prep. Sometimes we have small additional presentations, time for Q&A, troubleshooting sessions. These are still kind of to be determined, but we have this 30-minute extra session before lunch where we squeeze in some shorter things that maybe are useful but don't work as an entire module themselves. From 12 to 1, we'll have our lunch break. From 1 to 2:30, we'll have our second module, again, format relatively similar to module 1. After that, we'll have a 30-minute break from 2:30 to 3, followed by our final module from 3 o'clock to 4:30, and then from 4:30 to 5, usually we go a little longer than that. We have additional time for discussion, troubleshooting, and questions with the instructors from the day. So all of the instructors will rejoin at 4:30 and be available for questions as people need them. So the official time is 4:30 to 5, but we usually will go till 5:30, 5:45-ish. That time is flexible. But the idea of finishing a little bit early this year is that we will be providing a sort of non-required homework assignment at the end of each day that should take roughly an hour to do if people are interested in some additional work in the evening. Again, these assignments will be non-required. We know people have lives outside of this workshop, but we would like to try to finish a little bit earlier this year so that we can give people some time maybe to work on either the optional assignment for the day or maybe work on hackathon teaming or even get started on their hackathon project. So if you have any questions or concerns about the schedule, again, please feel free to let me know. We are, like I said, live streaming all of these sessions throughout the day. So if you can't make any particular session, they will be available usually within about an hour of each module. The processing on the live stream finishes and you can go back and watch them either later that night or during another day if you need to. All right, so a little bit about background knowledge and reading. So there are kind of 5 core areas that we think are not necessarily, you don't need to be an expert in any of these, but these are kind of the 5 core areas that contribute to a complete eventual expert knowledge of computational modeling, if that makes sense. You don't need to know all of these topics in depth, but it is helpful to know something about at least some of them. And again, we'll talk about all of these things during the workshop, but if you want to do some advanced preparation, we think that understanding things like the basic principles of modeling, so a little bit, you know, what Ariane and I were just talking about before, how do you take a system that exists in the real world and maybe has been studied experimentally and distill that down into something that a computer can crank out. You need to know a little bit about Python programming, which we'll talk about in a slide or two. A little bit about biological background, obviously. Some understanding of biophysics and some understanding of mathematics. And again, if you don't have background in any of these areas, it's perfectly fine. People come from all kinds of different backgrounds to this workshop. We just want to give you a little bit of maybe a primer up front so that you have some idea of where to look if you are interested in learning more beforehand. So a little bit about background principles of modeling, defining questions that can be answered by models. Not all questions are answerable computationally. So understanding how to ask questions that can be turned into computational models is important, and we will talk about that during the workshop. How to select meaningful variables, how to comb through experimental data and pick out your kind of starting parameters if you're trying to replicate an experimental setup computationally. How to conceptualize models so that they are conducive to computational setup. Deciding what components and mechanisms are important. Like we were talking about before, you often can't model every single thing about the system because it's too expensive computationally. It would take too long to run. But you can still create useful models of components of those systems that help you answer the questions that you're trying to ask without having to model every single piece that you would normally see in the real world. And then also understanding the limitations of models, so what they can and can't do, and how to interpret model output in a way that is useful is also important to understand. What are the limitations of what the computational model is showing us, and how did the assumptions we had to make about the model going in affect those outputs? So that's kind of also this question of validation and falsification, which we'll talk a little bit about during the workshop as well. You'll also need a little bit of background in Python programming. So we do offer our Python bootcamp, which will be on July 19th this year, and that will also be recorded and posted to YouTube. So there will be about 2 weeks, week and a half before the workshop starts, where if you don't have a chance to attend the Python workshop in person, you can review those videos. And we'll make sure again that you have all the links to that in your emails once those are available. But it is important. So Python, or excuse me, CompuCell is built on a kind of co-basis of XML model specification and then Python for actually running the model structure. And we'll get into that more during the workshop. But Python is an important thing to know when you're creating your own CompuCell models from scratch. So you need to know obviously basic syntax and indentation. Here we have an example of understanding the difference between 1 equal sign and 2 equal signs. You need to know a little bit about how loops work, Boolean logic, and conditional operations. It's useful to know a little bit about object types, object-oriented programming concepts. Our cells in CompuCell have a lot of inheritance in them. If you're familiar with Python, that'll make sense. If not, don't worry about it yet. But cell types inherit from each other, so it's important to understand about how to kind of create an object class and how those classes are instantiated within the simulation. You need to know a little bit about lists and dictionaries, which are something that are kind of key to a lot of Python applications, but don't tend to get covered a lot. Dictionaries are used a lot in CompuCell. Again, we'll cover those in the Python bootcamp if you're able to attend that. But yeah, the other thing is the self-dot class, so how to reference an object itself, and a little bit about how to write methods and how to assign attributes to functions and things like that. So again, you don't need to be a Python expert, but kind of a base level familiarity with some of the topics on this slide will help a lot going in. And again, if you aren't familiar with any of these things, if all of this is new, then we highly recommend that you attend our bootcamp because we will walk you through exactly everything you need to know to do CompuCell and nothing else during that bootcamp. There's a lot of resources out there for learning Python, oftentimes so many that it's overwhelming and hard to find the information you're looking for. So that's why we offer that boot camp, is so that you can be introduced only to what you need for the 2 weeks of the workshop. Again, it's also important to know a little bit about biological background. Again, I know people come from all kinds of different backgrounds. I know we have a large population of people coming from mathematics this year, not necessarily biological background. But you might want to do just a little bit of cursory reading on Wikipedia about some of the topics on this slide. Again, these things are useful to know. It's not necessary to know coming into the workshop. But if you're familiar with some of the biological terminology coming in, it will just make the learning process a good bit easier because you've seen these terms before. So things like, what are cells? What do they do? Seems like a simple question, but cells are actually very complicated, as it turns out. How do they generate forces? How do they move around? How are tissues constructed? So how do cells come together and stick together into cohesive tissue groups? Things like, what is cell polarity? What is planar cell polarity? How do those two things differ? We'll have a session on that in the second week. What is the extracellular matrix? How does it affect cell behavior? How is it generated? How do cells communicate with each other? How do these networks of communication relate to ultimate cell behaviors? How do biologists represent information? So if you don't have a biological background, understanding kind of how some of these cartoon diagrams, like the one on the right here of the cell walking process, there are some standardized representations of things, so kind of understanding a little bit about that is also useful. Again, you don't need to spend the next month, getting a bachelor's degree in biology. But it is useful to have looked at some of this stuff before, even if it doesn't make a whole lot of sense when you're looking at it. Just the process of, seeing it more than once can often help a lot. Kind of similarly with the biophysics piece, again, some things that are useful to know. On the right here, we have sort of a visual derivation of the diffusion equation. Diffusion is particularly important in cellular biophysics, but things like the ideal gas law, spring models become important in a lot of biophysical simulations. A lot of stuff gets reduced down to basically combinations of spring models. So understanding a little bit about that can be helpful. What is a constraint in a biophysical model? How do we constrain systems? Again, this question of what is diffusion? Diffusion is a big topic in computational biology. We'll have a whole module on that during the first week of the workshop. But again, a little bit of background reading never hurts. And then if you want to look into the basics of the cellular POTS model, which is how CompuCell runs, we find it to be pretty interesting. Again, you don't need to understand the fundamental physics behind it to make and run CompuCell simulations, but when it comes to the meaning-making process, it can be especially important to understand some of the mathematics of what's going on in the background. Speaking of mathematics, again, we know that not everybody's coming from a mathematical background. Sometimes the mathematics can be one of the hardest pieces to understand, especially when you're trying to write your own equations to represent a system that maybe hasn't been modeled before. So on this slide, I would say probably the most important thing to do a little bit of background reading on is first order differential equations and rate laws. If you've never had much experience with differential equations, that's probably the piece that is most important to understand, to kind of understand how these models are being iterated forward by the computer. And again, the partial differential equations kind of goes along with that. We won't be getting too deep into the hardcore mathematics of these simulations during our workshop, but we will talk about it a little bit. So again, if you want to do a little bit of reading on that, that may be helpful. Again, not required, just may be useful. So some places to fill in your background. Again, you can find these slides on the student materials folder. I'll post that link again because I know some people came in after we got started. Let me repost that in the chat. You can find that in the orientation subdirectory, this slide with these links. We have a couple of resources if you're not familiar with the principles of modeling. There's a very good paper on 10 simple rules for building your first mathematical models. And then we are actually currently in the the process of developing a online textbook on a lot of this content with a group called Embryo at Purdue. We have our prototype version of our online ebook up, and you can actually read the first chapter of that to kind of get an understanding of how to develop computational biological models. One thing to keep in mind, this website is currently undergoing some updating and content changes. So this content in this first chapter may change a little bit in how it's delivered, but the core content will remain the same. So if you want to take a look at that page, that may be helpful as well in kind of understanding how our group and many other groups out there think about how to approach the model conceptualization and construction process. If you need to learn a little bit about Python, again, the best way is just to come to our Python bootcamp or to view the videos after the fact if you can't attend in person. Other than that, if you'd like to do some prep beforehand, the official Python tutorial has gotten better and better over the years. Again, there's a lot of stuff in that tutorial. It's very in-depth. I think last year when we were recommending it to people, we were saying if you can get through chapter 3 or 4, that's probably a good stopping point. I will take a look at that again because they update that tutorial fairly regularly as new versions of Python come out. So I will make sure to look through that over this week, and we'll send out in the intro packages recommendations for where to stop on that tutorial, because after a certain point, it's a lot of information that you don't necessarily need for the workshop. In the past, we've often recommended the Python Village exercises from this Rosalind group. These are exercises you can do that actually have graded feedback to tell you if you've done them correctly or not. There's 6 exercises. If you can complete exercises 1 through 5, you're in pretty good shape for using CompuCell in the future. Again, you don't have to be able to complete exercises 1 through 5. That's just saying if you can work through exercises 1 through 5 and get them correct, then that's basically everything you need to use Python and CompuCell. We do have a good book recommendation here as well. Usually you can get those free through your institution. Most institutions are aligned with Springer in some way or another. If you can't find that book and you're having trouble finding other resources, please feel free to email me and we can try to direct you to some maybe customized resources that will help you learn exactly what you're trying to learn beforehand. We have some additional resources here for learning network modeling, mathematics, biology, and physics elements of it. Again, these are just starting points. Some of these textbooks, if you get taken to a page where the textbook is listed as like $200, don't freak out. You can drop the edition down, and usually the previous editions are very cheap. Again, we make discoveries in biology all the time, but the core principles of developmental biology don't change often enough to buy the very latest version of a textbook for 100% price increase. And then again, we have a link here to the original paper that was written on CompuCell. So if you'd like to learn more about kind of the genesis of CompuCell3D and the underlying algorithm, you can read the original paper that was published with the release of CompuCell in 1992, I believe. So again, if you find any other resources along the way while you're trying to learn this stuff, and you would like to suggest them to the group at large, please feel free to shoot me an email with a link or an attachment, and I can send them out to everybody else and also put them in our resources folder, which again is in that student materials directory that I linked in the chat. You don't have to look into any of this. It just is useful to have a little bit of familiarity coming in if you plan on using CompuCell heavily in the future. But this is all optional prep. So a few notes, quick notes on resources for the workshop. The CompuCell website obviously is one of our core resources. The workshop page itself will be updated relatively frequently with new information about schedule changes, or if there's been meetings before the workshop that have been scheduled, those will go up on the website. So please do keep an eye on the workshop page for information. I know there was some confusion about the Zoom links. If you're ever confused about the time or date for something, the listings on the website are kind of the authority on when things are happening for the workshop. So if there's ever any miscommunication between, Zoom meetings, if there's a typo in an email that I send, it does happen sometimes. The workshop webpage is, like I said, the final authority on times and dates. That doesn't mean there might not be a typo in the workshop. So if something is really glaringly wrong, please do let me know. And we can fix that on the website. But the website is the guide for time and links for everything. You can download CompuCell through CompuCell3D.org/sourcebin. There's an online help and manual. Again, these slides are available in student materials, so you can just go and click all these links. We do have a CompuCell Quick Start Guide, which kind of shows you a lot of the basics of getting some preliminary simulations set up. It's a little bit outdated. It's based on CompuCell 3.6. We're currently in 4.6, but a lot of the information is still the same, so it's still useful. Some of the images of the interface and everything might be a little bit outdated, but the core operations are the same. Again, we have our Slack channel and our Google Drive folder with all the materials. The student materials folder will be updated regularly as new materials are completed and ready to share. Again, Slack channel used for communication outside of the workshop time. During the actual workshop sessions, the Slack channel is not monitored as closely as it is when we are not currently teaching. So just something to keep in mind. It's a good way to get help with bug reports and things like that outside of workshop time. We usually have a couple of people that monitor the Slack during the workshop, but when the sessions are in progress, the Slack may not be monitored as closely. So just something to keep in mind there, but we do check it in the evenings to communicate with people. We have some quick reference guides. So these will actually be sent out by email in your introduction package, but if you need to get them again later, they are in the resources folder, which is linked here. Wonder, can't highlight that. So again, we'll send all these emails out, or all these links out in an email by the end of this week. Additional readings here, we do have some papers. Again, this 10 Simple Rules paper is in our resources folder, as well as a few other papers of simulations that have been written in CompuCell if you want to kind of skim some of these and get a feel for what official published work looks like in CompuCell. Any questions on resources, where to find things? It's pretty straightforward. The website and the student materials folder are the two most important places to find information. So go over some quick details about the hackathon real quick, and then we'll walk through an example simulation in CompuCell. Hackathon this year will be taking place from Friday, August 8th to Sunday, August 10th. That'll be 3 full days this year to give people time on the 8th to finalize their groups and get started on their projects, and then 2 days of project work on Saturday and Sunday. We'll be holding some hackathon project pitch meetings. We haven't set those dates yet, but we'll make sure to let everybody know as soon as we do. The idea here is you come and give a lightning talk of 3 to 5 minutes to pitch your idea. We do have a slide template for that to kind of give you an idea of what to present in those 3 to 5 minutes. You don't have to follow the template exactly, but that's just kind of what we think is most useful to know in a 5-minute quick presentation. You'll give a quick background and motivation of the problem you're trying to model, any information you currently have that you've already been working on about the model, and then what you're looking for in group members, essentially, are the 3 big pieces. We will help select a preliminary list of feasible projects. We're not saying these are the projects that you can do, but we're available to help people either come up with project ideas. If you have an idea and you're not sure how to turn it into a simulation, we can help with that. Or if you have an idea for a simulation that is maybe you feel too large and you're not sure how to tackle it, in a 3-day hackathon, we can help you scope your project down into something that is achievable in those 3 days. We're also available to help organize teams. Teams are largely self-organizing, at least they have been in the past years, but we are available to help suggest people to teams, or if you're somebody looking for group members, we can help pair you up with people before the start of the hackathon. We'll have, as far as the actual hackathon days work, we'll have check-ins in the morning and at noon with the whole group, so everybody will kind of come together to present where they're currently at in their hackathon project. But the bulk of the time will be spent in breakout rooms with your group working on your actual project. And then each evening we'll have a full group report so that everybody can kind of check in on their progress, ask any questions they have, and let us know what help they need the next day, so that we can have feedback for you the next morning and make sure that one of the instructors who's most able to help with your particular problems can spend some time with you the next day. At the end of the hackathon, we'll have a short oral presentation and model demonstration by each group so that everybody can see how everybody's model came out. And then after the hackathon, we do offer post-hackathon support. If your team wants to continue working on your project moving forward, we're happy to continue collaborating with you in that respect to help you generate, publication quality simulations. We have had papers that have come out of hackathon projects, so it isn't impossible to generate something really useful during the hackathon. But we found that hackathon projects tend to go very well, and groups come together with people from all different backgrounds. So even if you don't have a hackathon idea, or if you're not sure what you want to model, or even if you're not sure how to model exactly, we still find that people with particularly strong backgrounds in biology, for example, can be very important hackathon group members, particularly if a group is heavily coding oriented. Having somebody who's familiar with the biology to make sure that things are being done in a meaningful way is very useful. So there's a lot of different ways you can contribute to a hackathon group. You don't have to be a hardcore programmer to participate in the hackathon. If you're not sure what you want to model, but you do want to do a hackathon project, maybe even you want to lead one, reproducing existing models or existing papers using CompuCell is also a great way to approach a hackathon project if you don't have a specific idea. And we have a link here to a list of possible projects that we think are good for CompuCell reproduction. And again, we'll make sure that these links go out by email within the next day or two. Any questions about the hackathon before we move on? Quick note on expectations, I guess. We do, if you want to participate in the hackathon, we do like people to have, if you're hoping to lead a group, an idea of what you want to model and why. If you're hoping to join a group or just participate in another manner, having a shareable description of yourself and your skill set / background is very useful. Again, it's okay if you're a total beginner, but just having some idea of where people are coming from and maybe what they've done in the past can be very useful during that teaming process. Expectations you can have of us is that for those 3 days, we will be available, not necessarily 24/7, but maybe 12/7 for questions and assistance throughout the hackathon and then after the hackathon as well. So we will be in the meeting. We have a core set of instructors who kind of come in and circulate through the groups to help answer questions and debug things with you. I mentioned before this Python Village course. If you do intend to participate in the hackathon, it is very useful to be able to complete those first 5 exercises. Again, you don't have to be able to do that to participate in the hackathon, but if you're hoping to help with the programming process in particular, being able to get through those first 5 exercises in the Python Village is a good metric for determining what you still might need to know before the hackathon starts. See, I have one question in the chat. Is it possible to join the hackathon as an individual one-person team? Yes, we have had one-person teams in the past. We have found that it's usually helpful to have a couple of people helping you if people are available, just because 3 days is not a ton of time to go from idea to finished prototype simulation. I want to be clear there. We don't expect finished simulations, but something that is sort of in a working prototype phase. But we have had one-person groups in the past, and that's perfectly fine if you'd like to work on your project individually. But you may find that there are people in the other workshop attendees who maybe are very interested in your problem as well or doing similar work who can kind of help with that process. So we do encourage people to still put their project idea in our sharing document just to see if there's a whole lot of interest about it. But yes, you don't need to be in a team to participate in the hackathon. Okay, so I think these orientations are usually scheduled to be about 90 minutes. I understand that people have other obligations here and there, so we're going to move into our CompuCell tutorial here. If anybody does need to leave at 11, again, these slides are available in the student materials folder, and this recording will be available on YouTube. All right, so quick note on CompuCell structure. So CompuCell is kind of made up of two different pieces. There's this CompuCell player, which is a tool for running, visualizing, and interacting with your simulations. This is where all your output is shown, and how you can change parameters on the fly is through player. Twedit is the actual code development piece. So this is where you'll be changing all of your initial parameters, writing your Python code for actually running the simulation. But when you launch CompuCell, it will launch in player. You can launch Twedit by itself, but it's important to know going in that there's kind of these two pieces that talk to each other but aren't represented in the same big window like a lot of software is. We'll take a minute here to install and run CompuCell. So CompuCell takes a little bit of time to install, and so that we can get through the example, I don't want to sit and wait too long, but I will show people how to get started if you would like to start installing now. If you already have it installed, you can follow along. Again, if you don't have it installed yet, or if it's taking too long to install, don't worry. You can always refer back to these slides for step-by-step instructions on how to replicate the example I'm about to walk through. If you have a Linux or Mac system and you have trouble installing CompuCell, please get in touch with us right away. Generally, Windows installations go fairly smoothly. Mac has been making changes to their OS over the last few years that cause some issues here and there, depending on which chipset you have and how you install CompuCell. So if you have a Linux or Mac machine and you're having trouble installing, please let us know right away so we can set up some office hours for you to come get help. We can't guarantee that we'll have trouble or that we'll have time. I hope we can't guarantee that we'll have trouble, but we can't guarantee that we'll have time to troubleshoot issues during the workshop sessions. So once the sessions have started for each day, sometimes troubleshooting CompuCell can take some time. We do have breakout rooms available if you're really having problems with CompuCell that day. But what we've often found is that when you leave to go to a breakout room to debug your CompuCell installation, which can sometimes take 20 to 30 minutes, when you come back, you've missed 30 minutes of CompuCell content. So we recommend, if you are having issues with CompuCell during a workshop day, to just follow along as best you can with the actual content, and then we can help you maybe during the lunch break or at the end of the day with fixing your installation. So it is important that you try to get CompuCell installed and running properly in advance of the workshop. Again, if you're having any issues doing that, please contact me as soon as possible, and we'll set up a time to help you get it installed. So let me drop this link in the chat to our installation page. Pop-ups are killing me. So if you go to CompuCell3D.org/sourcebin, which I've just put in the chat here, you'll see at the top, there's an index of most recent releases. So on your end, it'll show 4.6 as the most recent. This picture is out of date. I need to replace that for future orientations, but current version is 4.6. There is a candidate release of 4.7 in the works. You can only get that through the official CompuCell GitHub right now. But for now, everybody, we recommend just installing 4.6 through the official installers. So you'll click on your platform, Windows, Mac, or Linux, and it'll take you to the page, section of the page for your platform. So if you're on Windows, it'll take you to a download link. For Mac, it'll take you to a set of commands to run. So up here under download, we'll go to binaries, which is the link I just sent. Here, I'll click on Windows. Again, for Windows, you'll click on this download link. It'll take you to a site called SourceForge, where you can just download the latest version and then run the executable, and it will install to your system. The installation can sometimes take upwards of 10 to 15 minutes, depending on your connection speed. So if it looks like it's just sitting there stuck on 90%, just let it sit. Sometimes it takes a while to kind of finalize the installation. If it's been 30 minutes to an hour and it's still not finished, something might have gone wrong with the installation. You can just close the installer and run it again. You don't have to uninstall. The installer will pick up where it left off. Another thing to know in Windows is it'll pop up a terminal window during the installation. Make sure that terminal window stays open. That's what's actually running the installer. You don't have to worry about that, but make sure that the terminal stays open throughout the installation. Don't accidentally close that, because that will abort the installation. For Macs, for M1 through M3 processors, so these are newer Mac platforms, you'll download the installer here. So again, it'll take you to SourceForge to download, and then you'll run the installer by putting the following commands into your terminal. If you've never used the terminal before, you just launch the terminal and run these commands. You'll have to change the file path here to where you actually downloaded the .sh file. But running these two will install CompuCell. And if you have an older Mac with an Intel processor, you can check which processor you have by just going to your Mac's About section, and it'll tell you, if you've got an Intel processor or if you've got an M1, M2, or M3 chip. You'll follow the same process. You'll download the installer with this link here, and then you'll run the following commands. Similarly on Linux, you can download the installer here and then run it using the commands. The Linux and Mac installations are essentially the same. There are instructions here if you're a little bit more advanced and you're computationally familiar with Conda. You can install using a Conda environment. Pedro, who has joined the meeting, actually has a tutorial up on YouTube on how to do that, if any of these steps are confusing. So if you're not familiar with Conda or with installing things purely through the terminal, we recommend downloading the package and installing as instructed up here. But if you do want to give a shot at installing through Conda using an isolated Conda environment, you can do it that way as well. So I think I'll give maybe 5 minutes here for people to attempt to at least download the package, see if you can get it installed. We can answer some brief questions if people are having trouble. Again, it'll take some time to install on most people's systems. So if we can get it installing, I'll go ahead and move on to the demo. Does anybody here already have CompuCell installed? You can feel free to either raise your hand or put a yes in the chat. Okay, so we've got 3. Mark and Ariane, I assume that means you have CompuCell installed, not that you need to ask a question. Zoom really needs 2 raised hands. raised hand emojis. One for questions and one for me. Okay, good. So we've got a few people who have it installed already. Again, if you'd like to go ahead and try to install it, we can wait a couple of minutes here just to make sure you get the process started. Any questions about installation so far? Everybody able to find the page we were just looking at?
I'm sorry, are you asking me?
No,
Are you,
Pedro,
did
I
you ask
assume
me
you can
something?
install CompuCell.
Yes, I can. I can help you guys if you need help. Sometimes people find um issues that they're not able to solve, and if that happens to you, then make a post on our subreddit. That's probably the quickest way to get access to my help. And if it's something really difficult, we can meet one-on-one.
Link to the not CompuCell ready. Yeah, our subreddit is kind of where this is kind of our community forum. With the link here. If you use Reddit, you can make a post here. Please also email me about the issue. But again, the Reddit, we have multiple people looking at the subreddit, so usually responses come in within 24 hours or so. But you can also email me about the problem when you post to Reddit, and I'll make sure that somebody gets put on it. Or that we set up a meeting time if you're having an issue, because it always depends on your personal computer's architecture. Some people, most of the time it installs okay, but every now and then we have an issue we haven't seen before, so we may have to make a meeting with you and sit down and actually look at what's happening to get it worked out. All right, so I think I will actually go ahead and start walking through this example. If anybody has questions, feel free to drop them in the chat. We can stop and back up if we need to. I'm going to move through this a little bit quickly. This is just to kind of show you how easy it is to actually set up a simulation in CompuCell. So I'm actually going to run CompuCell on my computer here. Again, when you launch CompuCell, it'll run this terminal. This terminal needs to stay open. If you're not familiar with, if you've done any computation in the past, you've definitely seen these terminals before. If you haven't, sometimes they look unfamiliar and look like, the movie version of a virus installing to your system. It's not, I promise. You can just minimize the terminal, and after a minute, CompuCell will launch. So when you first launch CompuCell, you'll see the player window, which we talked about before is one of the two pieces. And we also want to launch our editor, which is Twedit. So right now, nothing is loaded into my terminal or into my player, but we also want to launch Twedit. You can do that up here by this icon with the notepad and pen. I know that's tiny on my screen. You can also go to File, Start Twedit, and then it will launch our editor alongside player. All right, so today we're going to use Twedit Wizard to create a cell growth simulation in NanoHub. Sorry, in CompuCell3D, I need to take that NanoHub out. We're not using NanoHub this year. Don't worry about that. So I think maybe I'll try to do split screen here. Should work okay. Is that still big enough to see the text on the right? take. Yes, looks good. Okay, great. Thank you. Sorry, trying to see everything at once with the split screen is very difficult. All right, so we've launched Twedit. So we've done that step already. And we want to make a new simulation. So again, apologies that this says in nano how we meant to go take those out this morning. I slipped my mind. So the interface here is the same, but we'll be doing this with local installations this year. So to launch a new simulation, we go to CompuCell3D project, new CC3D project, and then you'll be greeted with what's called our wizard. So this is the basic simulation setup wizard that we have. It'll ask you a few questions, you choose a few options, and it will actually generate a code structure for you with everything that you've specified. Now, most simulations, you'll still need to go in and make changes to the code, obviously, but this just takes some of the pain out of writing code from scratch. So we're going to call this cell growth, and then you'll want to specify a directory where you know you have write access. So I'm actually going to change this to just my desktop for now. Change that to orientation demos. A couple of things to note about naming a simulation in CompuCell. Your simulation cannot start with a number or a special character like a period or a hyphen or things like that. It has to start with an uppercase or lowercase alphanumeric character. There are certain special characters that we recommend you not use. So you don't want to have spaces in your file name. You don't want to have periods in your file name or things like exclamations and question marks. Periods in the file name cause issues because it causes some of parts of the code to parse incorrectly because it, sees periods too early and thinks that that's the end of your file name. So we just recommend avoiding anything like special characters. If you need to have spaces, use underscores or hyphens instead. Actually, Pedro, I'm not sure. Is hyphens one of the characters we're supposed to avoid also? I think hyphens are okay.
I think you cannot do space. You cannot start with a number. I would avoid the hyphen.
Yeah. Yeah, so we recommend underscores. That's usually the safest special character if you need to add spaces to your file name. And we'll go over this again in the workshop in more depth. But if you want to mess around with CompuCell before the workshop, that's one thing to keep in mind. And again, make sure you have full write access to your simulation directory because CompuCell will allow you to save a file folder or a project folder to a directory where you do not have write access. And then when you try to run it, CompuCell will just crash without useful error output. So if you're running a simulation in CompuCell and it's just crashing, disappearing with no error messages, it usually means that you're trying to run a simulation somewhere where you don't have write access. Because it can't create the temporary files necessary to run the simulation. So just keep that in mind. Make sure you put it somewhere that you actually own. Try to avoid cloud folders and things like that. So once you specify your name and directory, we'll go ahead and leave it as Python plus XML for now, and click Next. Here we'll have so this is all creating a file. General simulation specification. So this is setting up the environment for the simulation. Basically, we have our lattice dimensions, X, Y, and Z dimensions, boundary conditions, lattice type, square or hex. We're going to leave it as square for now. CompuCell can run a hexagonal lattice, but for this example, we're using square lattice points. Average membrane fluctuations, excuse me. Pixel copy range, number of Monte Carlo steps. We're going to leave all this in its default state if you're following along right now. So what this will do is it will create a lattice of 256 pixels by 256 pixels in the X and Y direction with no flux boundaries. And it will use a rectangular slab initial cell layout, so it will generate cells in a square, basically. So we'll go ahead and click Next. Here we want to specify a couple of cell types. So this is where we actually put in our initial cells. You'll notice it starts with medium. All simulations in CompuCell must have a medium for the cells to sit in. So we'll leave that alone. We'll add 2 cell types for this simulation. We'll do cell 1. You can click Add here, or you can just simply type it in and press Enter. And you'll see once it's added to your specification table here, it's been successfully added to the simulation. So we've got cell 1, cell 2. That's all we need for now. Go ahead and click Next. Here we can specify chemical fields. We're not going to do that for this example, so we'll just go ahead and click Next, and it will leave the chemical fields plugin out of our simulation. This next page is probably your key wizard page. This is where you specify which cell properties and behaviors plugins you want in your simulation. We want our cells to have variable volume, that we want them to stick to each other, and we want them to grow and divide. So to do that, and again, this will all make more sense once we've had a chance to walk through it during the workshop. For now, we're just illustrating how quickly we can build simulations in Wizard. So to have our cells stick to each other, we want adhesion contact plugin. We want them to have variable volume, so volume local flex. And then we want them to grow and divide. So we want our growth plugin and our mitosis plugin. Once we have all those checked, we'll click Next. You'll notice here, one thing to note, when we clicked mitosis, some of the volume options went away. The mitosis plugin requires certain types of volume plugin. So usually it's best to specify your cell behaviors first, and then your constraints and forces may be narrowed down there. So again, we have contact, growth, mitosis, volume, local flex, and then we'll leave center of mass and cell neighbors checked. Click Next. You'll have your configuration complete window. And then we'll hit Finish. And congratulations, we've actually just created our very first CompuCell simulation. It's easy as that. So it'll take you back to your Twedit window. You'll notice now you have a project in your project manager folder. You can drop down to see which files are actually in it. If we double click on the cell growth project, it will populate our editor with our files. So you can then look through your XML file specification. And again, here you can see where some of this wizard stuff is. Here's our dimensions of the lattice, number of Monte Carlo simulation steps, temperature was our fluctuation amplitude, neighbor orders 1. Here we have our 2 cell types that we specified in Wizard. And then we have our plugins here, contact plugin, volume, which is actually tracked by the Python, but it's initialized here. And then we have a rectangular initializer that generates randomized cells in a rectangular slab. So we'll actually go ahead and, now that we've got this in Twedit, skip talking about saving, we can actually run in player. So what I'll do here, want that. We can right click on our project up at the top and then open in player. And sometimes the first time you run a simulation, sometimes it can take a minute to initialize, but it should start running in player. And here you can see our cells growing to the edge of the simulation lattice. And then if you look at any particular group of cells, you'll see that once they reach a certain volume, they split into 2. Just let this run for a minute. And here at the bottom in our console, you can see how many steps, Monte Carlo steps we've walked through. Again, I'm not going to get into too much detail about what we mean by Monte Carlo steps. Today, we have a whole module about that at the beginning of the workshop. Up here in the model editor is where we can actually change our values while the simulation is running. So this is handled by the Python stepables. We'll talk more about that in detail later. But once the simulation is running, we can actually change things in real time. If we wanted to change the temperature, for example, so this is how broad our fluctuations are. If we want to double the temperature, maybe. It didn't do much. Let's make it 50. You can see our cells start to become a little bit more frantic. Our edges are more chaotic. Change that back to 10. You'll see our simulation kind of evens out. You can change contact energy between different cell types. A number of different things you can change in real time here. So if you're interested in starting a simulation with a certain set of parameters, and then maybe exploring how changing different parameters causes behavior to change, you can do that using the model editor. You can add events, like specified events, if you need something to happen at a certain Monte Carlo step. So after 5,000 steps, if something needs to change in the simulation, you can set that up through Python stepables. We'll talk about how to do that during the workshop. So any questions about that? Was anybody following along? It's fine if you weren't. Oh yeah, one other thing. So up here we have our simulation controls. We can pause, stop, step, and play or run the simulation. So if we pause the simulation, it stops at its current Monte Carlo step, and then you can actually step it one Monte Carlo step forward by clicking this button. So if you want to look at it step by step and see how the simulation changes more slowly, you can do that. You can also stop the simulation, so it keeps it loaded in player, but now our simulation has been terminated. If you play from this point, it'll start over from the beginning of the simulation. So you can see here how that rectangular slab at the initial setting turns into our kind of growth and division model that reaches the edges of the lattice.
Is it possible to constrain the growth of that particular cells into a particular region and then divide in that particular region
Yes.
rather than spreading out like that?
Yeah, so you can do all kinds of stuff with your cell behaviors using the different plugins and specifying different kinds of Python stepables. This is just kind of our base level. We haven't changed anything simulation, so the cells just grow, until they hit the walls. But yes, you can absolutely set specific regions that do specific types of growth.
Okay.
And specific cell types as well. So you can give your cell types different behaviors. So if you want one cell to divide at a certain, so cell division is controlled by volume in CompuCell. Once it reaches a certain target volume, it splits into two cells. If you want one cell to divide at a smaller volume than the other, you can also do that. It's very flexible. So if you stop the simulation, you can also use, if you just want to see the initial setup, you can, instead of clicking play, you can click step, and it'll actually just show you the first step of the simulation. This is kind of how you would verify that your simulation has been set up properly, particularly if you're trying to use specific cell arrangements. We'll have a module on how to set up what's called a PIF file, which instead of having a randomized blob will allow you to set up like very specific each cell basically is set up manually if you need to start from a specific starting arrangement. Then you can step or play from there. So again, don't worry if you didn't follow all the details there. We'll have a whole week and a half, 2 weeks exploring these concepts. And again, these slides are available if you want to get CompuCell installed after this session and maybe try to replicate that simulation yourself. You can follow step by step there. So we have some extra slides here on CompuCell specification structure, but I think that in the interest of time, since we're coming up on 90 minutes here, I want to leave a little bit of time for questions. We can, if you're interested in looking at this ahead of time, you're welcome to, but we will talk more in detail about this during the workshop itself. This just gives you a quick overview of what the XML, how the XML specifies the initial state of the simulation, and then how the Python kind of clicks through each step and makes changes to that initial setup. So some quick final notes, things to do to prepare for the course. Again, make sure you can launch CompuCell on your local computer, that you can get it installed and that it launches properly. And the best way to check and make sure it's working, again, is to walk through that simulation setup we just did. Once you get it installed, if it sets up and runs properly, then your CompuCell is most likely installed correctly. Make sure you can load, edit, and save CompuCell simulations into Edit. Make sure the directories you're using, you have proper write access. And then we also recommend that you load and run some of the CompuCell3D demos. So your CompuCell installation will come with a folder full of demo simulations that you can look at. We recommend making sure that you can open and run these 3 simulations: deafable base mitosis, angiogenesis, and delta notch. This is kind of a good test to make sure that all of your CompuCell components installed properly. For background reading, you want to review any of the core concepts that you don't feel comfortable with. Again, you don't need to be an expert, but seeing some of the terms and ideas ahead of time will make encountering them during the workshop go a little bit more smoothly. If you're planning to participate in a hackathon, please think about a project that you want to do or what kind of project you might want to join. And we will have a quick survey within the next couple of weeks sent out for you to fill out some interest about your hackathon plans if you're planning on attending. If so, what you might want to do or how you might want our help finding a group. So with that, I am finished for today. That is the end of today's orientation. We have some time here for any questions people may have about anything we've talked about, CompuCell functionality, logistics of the course, hackathon, anything like that. Eunice, yes, you had a question?
Oh yeah, thank you for the presentation. And my friend just told me that he would love to join this workshop and hackathon too. Is it possible for them to still register now?
Yes, yeah. Registration is currently open until June 30th.
Oh, okay.
If they can't register by then, tell them just to shoot me an email and we can open the form back up for them. But yeah, registration is open until the end of this month. So.
I see. Thank you. Thank you so much.
Mark, yes, the other orientation sessions will be more or less identical to this one. It's the same material, so you do not need to attend another orientation if you've already come today. If anything particularly interesting comes up in the question and answer sections of the other orientations, we will let people know, maybe to go check the recording, but usually the orientations are all identical.